Hello friends, today we are going to discuss here statistics book number 2 here. In this book number 2, unit number 9 here, measures of variation. This is the unit 1. And in this unit you will find when we have given quantitative data, it is more spread over scattered. Instead of calculation of measures of central tendency, the measures of dispersion or measures of variations is calculated here. In the scattered data, average does not give the proper representation. Therefore, it must be stated that meaning of variation or dispersion here. And this dispersion here is one of the example is given here. In the scored cricket, batsmen have 3 one-day matches as the given below. First match, Sachin scored 100 runs, then Rahul scored 100 runs, and Yuvraj scored 0 runs here. In second match, Sachin scored 100, Rahul scored 50, and Yuvraj scored 295. In third test match here, Sachin scored 100, Rahul 150, and Yuvraj 5. Here the total of each sportsman or batsman is equal 1. Here one of the average here by Sachin is 100, by Rahul is also 100, and by Yuvraj is also 101. Here you will see that such types of example here, dispersion of each batsman. Now you will observe that the average run scored by the 3 batsmen is equal, that is 100. But it does not mean that all of them are equally good batsmen here. Certainly their answer should be no. Now if we want to select batsman for the next match, we will select Sachin because here he has scored uh, quite equal 100, 100, 100. There are 4 measures of dispersion here: range, quartile deviation, mean deviation, and standard deviation. Here range means it is the just difference between highest and lowest value of the data. It is called range here. The formula here is find out here H minus L. That means H is the highest one and L means the lowest value. Then for the comparison, you require relative measures such as coefficient of range also. The formula for this one is also known as coefficient of range, H minus L upon H plus L here. Then for example, it is given here the example, the following data is price of 2 commodities here in 8 different cities. Commodity A price is 18, 20, 25, 24, 16, 20, and 21 here, 26 here. Then here you will find the commodity B is also for the first one 30, for second 32, then 31, 35, 34, 33, 32, and 31 here. So here first commodity A is given, range is highest, that means most highest figure is 26 and lowest figure is 16. That means it is range highest minus lowest, it will be 10. And for commodity B, you will find highest is 35 and lowest is 30. That means range here 35 minus 30 is equal to 5 here. The coefficient of range is here the 26 minus 16 upon 26 plus 16, that means 10 upon 42 is equal to 0.2381. Here is the coefficient of range for product A also. Then here for product B, you will find that coefficient of range is equal to 35 minus 30 upon 35 plus 30. That means 5 upon 65. That will be the answer will be 0.0769. This is the answer for product coefficient of range product B also. Here range generally used for the higher sensitivity of prices like gold, silver, etc. In general sense, we use this term like asking the marks of the any D class of student or giving it between the range between 50 to 60, that we give only range of the passing percentage of that class also here. Then there are some merits and demerits of these type of range also. There are some merits here. Merits, it is range is easy to understand. That means we can easily understand such merits of this range also. Then second merit is that it is easy to calculate. There is no difficulty in calculation of this range. Third merit is for the small sample, it is very good measure. Then there are some, there is also one demerit of this range also. It is not based on all observations in this data. This is one of the demerits of the range also. Then there are test questions. Suppose here, what is the meaning of the dispersion or variation? The short answer type question. Those questions are also answered at the end of each unit or end of the each session also. Then you will find here the fourth question here. Calculate the range and coefficient of range of the following data and decide the group which is more consistent here. Here you will find marks of group A. Here those marks are given. Then those marks are given here 42, 45, 47, 35, 39, 40, 46, 38, 43 and 41 here. And the marks of group B are given here. Group B marks are 55, 70, 35, 60, 65, 80, 73, 42 and 53 and 57. For the group A, you will find here the highest of group A is 46 and lowest is 35. That means difference or range is equal to 46 minus 35 is equal to 11. Now you have to find the coefficient of range. The formula is that H minus L upon H plus L. That means here 46 minus 35 upon 46 plus 35. That means 11 upon 40, 81. The answer will be 0.1358. This is the coefficient of range here for group A. Then for group B, you will find the highest value is 80 and lowest value is 35. So the range will be 80 minus 35 is equal to 45. And the coefficient of range will be H. The formula is that H minus L upon H plus L. Here 80 minus 35 and upon 80 plus 35. That means you will find here 45 upon 115. That means the answer will be 0.3913. This is the coefficient of range. That means comparing with A and B group, you will find that A group is more consistent one. Then you will find here quartile deviation. In the first method range, we take only two values in for the calculation. highest and lowest. All middle values are not considered here. Therefore, now in the second method, quartile deviation is one of them. Here we first find Q1 and Q2 quartile, that is quartile 25 and quartile 50 also. Interquartile range, the formula is that there is Q3 minus Q1. Q3 means quartile third and minus quartile 1. Here, for example, is given here, quartile deviation is equal to Q3 minus Q1 upon 2. This is the formula also. Then coefficient of quartile deviation is equal to Q3 minus Q1 upon Q3 plus Q1. Then for example, here it is the given example for here. For the following set of observations, we calculate quartile 3 and quartile 1 here. 2, 5, 8, 10, 16, 20, 22, 24, 29, 30 and 32. Here numbers are 11 here. And quartile 1, the formula is n plus 1 upon 4. That means 11 plus 1 upon 4. That means 12 divided by 4 is equal to here 3 also. Then you will find here the quartile 1 is equal to 3. Here third number is here 8 is the quartile 1 here. Then quartile 1 here coefficient n plus 1 upon 4 observation. That means here third observation, that is quartile 1 is here 8 also. This is the first answer. Now we have to find the quartile third here. You will find that quartile 3, the formula is that Q3 here minus Q1 upon 2. That means here total here highest number is 29 minus 8 upon 2, 21 upon 2. That means answer will be 10.5 here. Now we shall see the example of group data. Here group data example is given here. Now we see the, for example, there are some class, then frequency and total cumulative class here. 0 to 10, 25 frequency, total will be 22. Then 10 to 20, there are frequency 28 and the cumulative frequency, it is the total of 22 plus 28 will be 50 here. Then third is class is 20 to 30 and frequency is 46 here. Then you will find cumulative frequency is 50 plus 46, 96. Then next is 30 to 40, 35, cumulative frequency 131. Then 40 to 50, frequency is 19. The total cumulative frequency is 150 here. Then here total number of n is equal to 150 here. Then to find out quartile 1 here, there is a formula that n upon fourth observation. That means here 150 upon 4. Then you will find the 37 point here. 37.5 is the observation. Here it is 37.5 lies in the class 10 to 20 first quartile class here. And the formula is that quartile 1 is equal to L1 plus n upon 4 minus CF bracket complete upon frequency multiplied by I. That means here quartile 1 is equal to 10 plus 37.5 minus cumulative frequency of the previous class 22 upon total here 20 frequency of that class 28 multiplied by difference is 10 here. Now you will find here 10 plus 15.5 upon 28 multiplied by 10. Then you will find the answer 10 plus 5.535 is equal to 15.535. To find the third quartile here, get the formula is here into bracket 3n upon 4 th formula observation here. Here 3 upon 150 upon 4. That means here 112.5 observation here. And it will be in the class of 30 to 40. It is third quartile formula is that quartile 3 is equal to L1 plus 3 upon n upon 4 minus C, cumulative frequency of the previous class, upon frequency multiplied by I. Then here L1 is 30, then third upon n multiplied upon 4, that means 112.5. Previous class cumulative frequency 96 divided by 35 frequency of that class multiplied by 10. That means here the answer will be 34.71 here. The quartile deviation will be Q3 minus Q1 upon 2. That means here 34.71 minus 15.54 upon 2. The answer will be 9.585. Then coefficient of this quartile deviation, the formula is that Q3 minus Q1, that is quartile deviation first, upon Q3 plus Q1. Here the figures are 19.17 upon 50.25. The answer will be 0.3815. So in this way, these are the quartile 3 and quartile 1 here. There are also some merits and demerits of quartile deviation. Merits are of those merits are of three types. First merit is it is easy to understand. Then second merit is it is based on the middle 50 observations, thus it is not affected by the extreme values also. Then third merit is that it can be calculated for open and end class also. There are some demerits also, those are of three numbers. It is not based on all observations. First demerit. Second, it is not capable for the further statistical analysis. And third is it does not consider the observations in the first and last quarter also. Then there are some questions at the test yourself here are given. So first question you will find that calculate the quartile deviation for the following set of observation. Here the set of observation is given 34, 37, 32, 22, 25, then 40, 45, 50, 42, 39, 47, and 55. So these are the set of observations here. Now we have to arrange this data here serially. The lowest number here is 25. So arranging the data here, 25, 32, then 34, 37, 39, 40, 42, 45, 47, 50, and 55. So these are the 11 numbers here. First, we have to arrange this data serially here from lower to the higher one. Now here, quartile 1 is equal to, the formula is that n plus 1 upon 4, th observation. Here total number are 11 here. So 11 plus 1 upon 4, that means here 12 divided by 4 is equal to third observation. And the third observation is here 34 here. So the quartile deviation of the 1 is 34 is the answer. Now we have to find out the quartile third deviation. Q3, the formula is that into bracket 3n plus 1 upon 4 th observation. So here 11 plus 1, here you will find 12 upon 4 multiplied by 3, that means 9, 3 into 3, that is ninth observation, and here ninth observation is the 47. So quartile 3 is equal to 47 here. Now here coefficient of quartile deviation Q3 minus Q1 upon 2, that means here 47 minus 32, 34 divided by 2, that means here 13 divided by 2 is equal to 6.5. This is the answer here. Each question is answer given at the end of each unit also. The second example of here is group data here. You will find here the group data, that is here calculate the quartile deviation from the following frequency distribution. Here daily wages are given from 0 to 10, number of workers 10, then 10 to 20, number of workers 17, then 20 to 30, number of workers 26, 30 to 40, number of 30, then 40 to 50, number is 33, 50 to 60, 25, 60 to 70, 12, and 70 to 80, 9. So these are the daily wages are given and their workers are given. Here we have to find such answer is given at the end of this unit. You will find also the answer is we are given at the end of this unit. Here also you will find this answer here 0 to 10, 10 workers, then cumulative frequency 10, 10 to 20, 17, cumulative will be 27, 20 to 30, 26, cumulative will be 53, then 30 to 40, 30, then cumulative will be 83, 40 to 50, 33, cumulation will be 116, 50 to 60, 25, cumulative frequency will be 141, then 60 to 70, 12, then cumulative will be 153, and 70 to 89, cumulative will be 162. Here that number are 162. Then here n upon 4, this is the formula. That means 160 upon 4 will be 40.5 th observation. The first quartile class is here 20 to 30. The formula is that of the group data, quartile 1 is equal to L1 plus into bracket n upon 4 minus cumulative frequency of the previous class divided by frequency multiplied by I. That means here L1 is 20 into bracket plus here 45, 40 plus 40.55 minus 27 upon 26 bracket complete into 10. That means here the answer will be 25.9 here quartile 1. Now quartile third deviation is here. Formula is that 3 into bracket 163, 3n upon 4. That means 162 upon 4 multiplied by 3. Answer will be 121.5 th observation. It lies in the class of 50 to 60 here. Quartile 3 formula is that L1 plus 3n upon 4 minus Cf upon frequency multiplied by I here. 50 is the L1 here. 1215 minus 116 upon 25 multiplied by 10. Here answer will be 52.2 here. Now quartile deviation will be, the formula is that Q3 minus Q1, quartile 3 minus quartile 1 upon 2. That means here 52.2 minus 25.19 divided by 2. Answer will be 13.505. This is the answer. So each questions and those answers are given at the end of these such units also. You have to solve all those questions and those answers given at the end of each unit. Here also you will find third question, find the coefficient of quartile deviation, class and frequencies are given here. Then here point number 99 is given here, the mean deviation or average deviation here. You must have observed that these means dispersion, we take some of the deviation difference first, method range, then higher and there, then calculate figure. Now mean deviation from raw data is given here. Now better difference can be difference from central value, that is average, because average is the calculated for all average in the data. Here only important point is to remember that when we take difference from this average, we have to take absolute or models values, because some differences can negative, so to make them positive, absolute deviation is taken. Since we have seen three types of average, that is mean, median and mode, therefore there are three types of mean deviation of average deviation also. It can be denoted by MDX, MDM, and MDZ. That is mean deviation from mean deviation from median, mean deviation from mode, mean deviation. Now first point number 991 here, mean deviation from raw data. For the set of raw observations, the formula can be given by mean deviation x bar is equal to summation L x minus x bar 1 then upon n here. Mean deviation from median summation into bracket x minus m bracket complete upon n. Then mean deviation from mode in summation into bracket x minus z upon n here. For comparison of required relatives means here coefficient of mean deviation from mean, that means mean deviation from x bar upon n. Then second is coefficient of mean deviation from median upon m, that is mean. Then coefficient of mean deviation from mode, then mean deviation from mode, then here upon z also. For example is given here, for the set of following observations you have to find such answers also. Here set is given here, 12, then 15, then here 18, 20, 25, and 18 here. We will see all these three types of mean deviation first arranged is in this column here. Those data is arranged here in x, 12, 15, 18, 18, and 20. 18 is double. Then x minus x bar, that means here x is calculated here, mean is 18 here. Here you will find that 18 minus 12 is equal to 6, then 18 minus 15 minus 3, then 18 minus 18 0, 18 minus 18 0, 20 minus 18 2, then 25 minus 18 is equal to 7. In third column, x minus x bar, here we have to make it positive. Minus 6 it will be positive, plus 6, minus 3 it will be positive 3, 0 0 0 0, then 2 is positive 1 2, 7 is positive 7 here. The total of this third column you will find that 6 plus 3 9, 9 plus 2 is equal to 11, 11 plus 7 is equal to 18 here. In fourth column you will find that x minus m, here minus 6 minus 3, the same as the column number 2 here, 0 0, then 2 and 7 here. In fifth column x minus m, again they are the same as the column number 3. Minus is changed into plus sign here, minus 6, that is 6, then minus 3 3, 0 0 0 0, 2 is 2, and 7 is 7. Then fifth column 1 2 1 2 3 4 5, sixth column x minus x z is equal to minus 6 minus 3 0 0 2 2. Then last column we will find again here such as 6 3 0 0 2 7 here. The total will be 18 here. So here measures of central tendency and their variations is 38 here. 38 here. Then you will find AM x bar is equal to summation x upon n. Here total is 108 here number, and total numbers are here 6, n is 6, and 108 divided by 6 is equal to 18 here. Here median is 18 plus 18 divided by 2, that means 36 divided by 2 will be 18, and mode is also here occurs more times. Mode is the number which occurs more time, that is called mode here. Now here you will find mean deviation from mean. The formula is that mean deviation from x bar is equal to summation into bracket x minus x bar upon n. That means here 18 upon 6, that will be 3 also. Then mean deviation from median, MDM is equal to summation into bracket x minus m upon n. The same answer will be 18 divided by 6 will be 3 here. The mean deviation from mode, the formula is that mean deviation z is equal to summation into bracket x minus z upon n. The answer will be 18 upon 6, that is the 3 here. Now note that here by chance all the 3 deviations are the same. Mean is same here, 3, median is 3, node is also 3. It may not be necessary because by chance the answer came as equal 3 here. Now here mean deviation from mean, that means MD X bar for ungroup and group frequency distribution. For ungrouped data you will find the example here. Here we first calculate the arithmetic mean and by an usual formula of here is x bar is equal to summation fx upon summation f. Then mean deviation from x bar is equal to summation x minus x bar into upon f minus summation minus f also. Relative measure is given by the coefficient of mean deviation from mean here. Coefficient of mean deviation from mean is equal to md x bar upon x bar here. After calculating mean, take differences from the mean of all values of x which are absolutely deviation from the calculate mean deviation x bar here. The example is given here x 5 10, 15, 20, 25. Frequency is given here 2, 5, 8, 3, 2. The total of frequency you will find that 2 plus 5, 7, 7 plus 8, 15, 15 plus 3, 18, and 18 plus 2 is 20 here. Here fx is there. Fx means 5 into 2 is equal to 10. Multiplication of x and f here. Then 10 into 5, 50. Then 15 into 8, 120. Then 20 into 3, 60. And 20 into 2, 50. Here this total is of fx is 290 here. Then x minus x bar, that means here you will find that 10 first, then second is 5. Difference between such bar, then 0, then here 5, 20 minus 15, then here 25 minus 15 is equal to 10. The total will be 30 here. Then last column, f into bracket x minus x bar here. X minus x bar here 15 and 10 into 2 20, then 5 into 5 25, then 8 into 0 is 0, then 5 into 3 15 and 10 into 2 20. The total of this is 80 here. Now the x bar is equal to summation fx upon summation f. Here the total fx is 290 and the total f frequency is 20 here. Then the answer will be here 14.5 here. Here you can take approximately value 14.5, that means 15, to avoid those decimal points here. Now you can observe that we get deviation column and finally get last column which frequently multiplied by deviation also. Now here mean deviation from mean is equal to summation f into bracket x minus x bar bracket complete upon summation f. Here 80 total last column is 80 divided by 20. The mean deviation from average or mean is equal to 4 here. So here is the another example also given from the mean deviation from median. Also, sir, the coefficient of mean deviation from mean is here 4 upon 15. That means 0.266 or 0. That means approximately we can take it 27 here. Now the second here is also for the group data is given here. That is of group data here 10 to 20 frequency is 6, then 20 to 30 frequency 10, 30 to 40 frequency 20, then 40 to 50 10, then 50 to 60 it is 4 here. Now in the third column, you will find that here 15, then 25, midpoint here. It is the midpoint. 10 to 20, midpoint will be, because there is difference of 10. So 10 into 5, 15, 20 into 5, 20 plus 5, 25, 30 plus 5, 35, 40 plus 5, 45, and 50 plus 5, 55 here. Then in the fourth column, you will find that there is multiplication of second and third column. 6 multiplied by 15 is equal to 90. Then 25 multiplied by 10, 250. 35 multiplied by 20, 700. 45 multiplied by 10, 450. And 55 multiplied by 4, 220. The total of these column, second 50 and fourth column is also 1710 here. Then here you will find x minus x bar. That means here first is 19, then second is 9, third is 1, fourth is 11, and fifth is 21. Now here in the last column you will find the multiplication of second column and this fifth column here also. That means 19 multiplied by 6. The multiplication will be 114. Then 9 multiplied by 10, 90. 20 multiplied by 1, 20. 10 multiplied by 11, 111. Then 21 multiplied by 4 is equal to 84 here. The total of this last column is 4 plus 4, 8, then 1 plus 9 plus 2 plus 1 plus 8, 18, then here 1 plus 2, 28, then 418 here. This is the total here. Now here x bar is equal to summation fx upon summation f here. That means here 34.4, approximately 34 here. Mean deviation from mean is equal to summation f into bracket x minus x bar upon summation f. That means here total 418 divided by 50. Approximately the answer will be 8.36 here. Now coefficient of mean deviation x bar is equal to mean deviation x bar upon x bar. Here 8.36 divided by 34, approximately the answer will be 0.245. Now here mean deviation from median also. Here now we shall calculate the first median for the data. Remember that to find the median, we have given arrange the data in increasing order if it is not given with the order. For ungrouped frequency distribution, calculate for cumulative frequency here. Then median is equal to n plus 1 upon 2 th observation. And if it is group frequency distribution, then we have to use this formula. Median is equal to n1 plus into bracket n upon 2 minus cumulative frequency bracket complete upon frequency multiplied by I. That means difference of classes. Once you calculate median, then take absolute deviation from mean also here. And the mean deviation from median is equal to summation f into bracket x minus x bar upon summation f. Relative measure is given by the coefficient of median mean deviation from median. Coefficient of mean deviation from median. The formula is mean deviation upon m here. Now here you will find the example here. Class frequency cumulative midpoint, then x minus m f into bracket x minus m here. Class is given here 30 to 34 frequency 4, 50, 35 to 39 frequency 10, 40 to 44 frequency 20, 45 to 49 frequency 12, 50 to 54 frequency 10, 55 to 59 frequency 8 here. Then you will find the cumulative frequency here. 4 first, 4, then second 10 plus 4, 15, 14, then 14 plus 20, 34, 34 plus 12, 46, 46 plus 10, 56, and 56 plus 8 is equal to 64. So here total number is 64 here. Now in the fourth column, you will find the midpoint here. Difference between 30 to 34, that is 4 difference. That means you have to add 30 plus 2, that means 32. 35 plus 2, 37, 40 plus 2, 42, 45 plus 2, 47, 50 plus 2, 52, and 45 plus 2, 57 here. Now the x minus m, that means here first is 10, second is 5, third is 42. Then this 42 is taken as a midpoint, median here. Then 47 minus 42, 5. Then 52 minus 7, 47, 10. And 57 minus 47, 15 here. Then in the last column, you will find that there is multiplication of second column and this for the fifth column here. 10 into 4, 40. 10 into 5, 50. 20 into 0, 0. 12 into 5, 60, 10 into 10, 100, and 8 into 15, 120. So the total of this last 6 column is 370. Now here number is 64. That means the formula n upon 2, that means 64 divided by 2. That means 32nd observation. And here 32nd observation lies in the class of 40 to 44 here. That is 49.2, 44.5 here. Remember that these are the two limits here. Now m is equal to formula here L1 plus n upon 2 minus cf bracket complete upon f into I here. So here the L1 is 40 here. Then previous class plus into bracket 32 minus 14 bracket complete upon 20 multiplied by 44.5 minus 39.5 here. The answer will be here 40 plus 8 upon 20 multiplied by 5 is equal to 40 plus 40 upon 20, that means 40 plus 2, the 42 will be the answer here. Now after calculating the deviation or multiply deviation by respective frequency here, last column, then calculate mean deviation of mode, median. Here summation f into bracket x minus m bracket complete upon summation f is equal to 370, which is the total here, upon 64. That means the answer will be 5.7812 here. Important point to remember is that this mean deviation is calculated from median is less than if it is calculated from mean and mode. Here mean deviation from mode is also given. Here we first calculate the value of mode, then mean deviation from mode from given. It is given here the formula mean deviation from mode is equal to summation f into bracket x minus z or mode upon f here. To calculate the coefficient of mean deviation from mode is equal to mean deviation from mode upon mode here. Here is the example is also given for you. Example here for wages in rupees and number of persons here given. Wages in rupees 20, number of persons 5. Wages in rupees 22, number of persons 8. 24, 10, 26, 15, 28, 12, and 38 here. Now in the third column here, it is you will find that z is equal to 26, x minus z. Here 26 minus 26, 26 minus 22, 4, 26 minus 24, 2, 26 minus 26, 0, 28 minus 26, 2, and 30 minus 26, 4 here. In the last column, you will have to make the multiplication of second column and third column here. 5 into 6, 30. 8 into 4, 32. 10 into 2, 20. 15 multiplied by 0. Remember that any number which is multiplied by 0, the answer will be 0. So here 15 multiplied by 0, 0. 12 into 2, 24, 8 into 4, 32 here. Now here the total of second column 53 and total of fourth column 130. Now here observe that the highest frequency is 15 here. The number of persons that is highest one is 15 here, and corresponding its value of mode is 26 here. Now take the deviation of mode to each value of x here. Then multiply these deviations by respective frequencies also. Now mean deviation from mode. The formula is that mean deviation from mode is equal to summation f into bracket x minus z, that is mode, upon summation frequency. That means here 138 divided by 53. The answer will be here 2.60. The coefficient of mean deviation from mode is equal to 2.60 divided by 26. The answer will be 0.1 here. Now this is from ungrouped data. For the group data, you will find the example here. Example is given here: 5 to 10 frequency 6, 10 to 15 frequency 12, 15 to 20 20, 20 to 25 15, and 25 to 38 here. Now the frequency total is here 61. Now you have to find the difference here. Third column 7.5, 12.5, 17.5, 12.22.5 and 27.5. Now here x minus mode z, here the difference will be here 10.5, 5.5, 0.5. That means 17.5 minus 17, 0.5. Then 22.5 minus 17, 4.5. Then here 9.5 is the last one. In the last column, it is multiplication of second column and this fourth column. 10.5 multiplied by 6, 63. Then 12 multiplied by 5.5, 66. 20 multiplied by 0.5, 10. 15 multiplied by 4.5, and that is 66.5. And 8 multiplied by 9.5 will be the 76 here. The total of the last column is 282.5, and this total of the second column is 61 here. Now first calculate the mode here. Modal class is 15 to 20. Now mode is equal to L1 plus into bracket D1, that is deviation 1 upon D1 plus D2, bracket complete into I here. L1 here 15 into bracket plus 8 upon 8 plus 5 multiplied by 5 is equal to 15 multiplied 15 plus 40 divided by 13. That means approximately 15 plus 3.076. The answer will be here 18.076, approximately 18 here. Now here you will find such example. Now mean deviation from mode also. The mean deviation from mode here summation f into bracket x minus mode in upon summation f. The total here 282.5 divided by 61. The answer will be 4.63 here. The coefficient of mode is 4.63 divided by 18. That means approximately here 0.25. There are some merits and demerits also. Merits are easy to understand. Then second one, it is value of minimum when it is calculated median. Third one, it takes the deviation from all averages. Therefore, it is better than range and quartile deviation also. Then there are some demerits. There are two demerits. It ignores the negative signs in the deviation and absolute values are considered. It is also, it requires many calculations for the first to get average and average deviations also. There are some test problems for you, some fill in the blanks, then calculate mean deviation from mean and median also. Then there are some summary and examples are also given here also. There are some of the standard deviation from raw data here. The standard deviation from raw data is formula is given here. The formula is that here stand for the standard deviation. You will find the observations. It is the positive square root of the mean of the square deviation. When the deviations are taken from arithmetic mean, in the previous method, absolute deviations we take differences positive by taking module sign. Now we take the difference and then square these values, then take the mean of these deviations. The name itself suggests that this deviation is standard one. Here is the formula. Standard deviation is under root summation x square upon n minus x bar square here, where x bar is summation x upon n here. Standard deviation is of group data. Here the example is given here for you. Standard deviation from group data. The square standard deviation is known as a pseudo variance. It is denoted by standard deviation square. There is example here, marks 10, 20, 30, 40, 50 and 50, 60 here. Number of them, that is frequency for 10, 5, for 20, 10, for 30, 15, for 40, 15, for 50, 10 and for 60, 5. The total is here 60 here. Now apex, that means multiplication of 10 into 5, 50, 20 into 10, 200, 30 into 15, 450, 40 into 15, 600, 50 into 10, 500, and 60 into 5, 300. The total of these is 2500. Now we have to make the square of it. That means here 5 into 10, 50 into 10, 500, then 200 multiplied by 24,000, then 450 multiplied by 30, 10,500, then 600 multiplied by 40, 24,000, 500 multiplied by 50, 25,000, and 300 multiplied by 60, 90,000. The total of this last column is 154,000, and the total of fourth column is 2,500 also here. Then here you will find the next calculations are given here. Standard deviation is equal to under root 1 lakh 54,000 divided by 60 minus 35 bracket square here also. Then here under root 2566.67 minus 1225 is equal to under root 1341.67. That means the answer will be here 36.63. Now the second example, illustration 3, group data 0 to 10, 8, 10 to 20, 10, 20 to 30, 20, 30 to 40, 10, and 40 to 50, 2 here. Now the total is 50. Now the midpoint is taken 5, 15, 25, 35, 45. Now apex, that means multiplication of second column and third column. 8 into 5, 40. 10 into 15, 150. 20 into 25, 500. Then 10 into 35, 350. And 45 multiplied by 2, 90 here. The total of this column is 1130. Then here multiplication of here 40 into 5, 200, 150 into 15, 2250, 500 into 25, 1000, sorry, 12,500, 350 multiplied by 35, 12,250, and 90 multiplied by 45, 4,050. Here the total of this last column is 31,200. Then here you will, but you will find that this total of this last column is 31,200 here. Then here summation x bar is equal to fx minus upon summation f, that means 22.6 here. Standard deviation is equal to under root summation fx square upon summation f minus x bar square here. That means here 31,250. Remember that this total of this last column here is the wrong one because it is taken here 31,200 and now it is total here 31,250. That means this total is wrong one. It must be 31,250 here. It is printing mistake here. So 31,000 under root 31,250 upon 50 minus 22.6 bracket square. That means here under root 6 25 minus 510 076. The answer will be under root 1142.4 here. The answer is 10.68 here. Now there is also shortcut method, but we have to use the example is given for shortcut method. That means sometimes calculation mean of shortcut method, alternative method can be used for calculation of standard deviation. Here shortcut method u is taken x minus a, assume mean upon c. A is assume mean or any value of x and c is the width of the class. Then standard deviation can be denoted by that sign also. Here is the example for you given here. Standard deviation where standard deviation is equal to under root summation f u minus u bar bracket square upon summation f here. That means summation under root summation fu square upon summation f minus u bar here. The example here is given. Latest shortcut method is also given here. Mark 0 to 10 number of students 8, 10 to 20 number of students 10, 20 to 30 20, 30 to 40 10, then 40 to 50 2. The total is here 50 number. Now we have to take the midpoint here also. Midpoint is 5, 15, 25, 35, 45. Assume mean here u is equal to x minus 20 upon 25 minus 10. Here minus 2, then minus 1, 0, 1, 2. Then here in the fifth column, a multiplication of second column and this fourth column. 8 into minus 2 is equal to minus 16. Then 10 into minus 1 is equal to minus 10. 20 into 0, it will be 0. Then 10 into 1, 10. Then 2 into 2, 4. The total of this column is minus 16, minus 10, minus 26, minus 14 is equal to minus 12 here. The last column you will see that it is multiplication of the fifth column and fourth column. Here minus 16 multiplied by 2, 32. Then minus 10 multiplied by 10, 10, 0 into 0, 0, 10 into 1, 10, and 4 into 2, 8 here. This will be the total of this is 60. Now the answer for this is also as 1.0688 also here. We shall stop here.